Hello, my name is Arshan Islami. I'm a consultant here at Aquent DEV6, and today we're going to be talking about A-Frame and some AR web experiences that you can build with it. Let's get started. So, if you're a web developer and if you wanted to get into the VR and AR space, we're going to talk about some of the technologies you can use to give you a little bit of a head start. First of all, we're going to talk about A-Frame. And afterwards, since we're going to be specifically talking about AR applications, we're going to talk about some detection APIs that we're going to be using. Okay, so what is A-Frame? So A-Frame is an extraction layer for 3JS. 3JS is a library that you can use to display 3D graphics in the browser. Just like most of these 3D graphics libraries, it uses a canvas to draw on your screen and has its own rendering engine. And this is shown pretty well. Most of these engines, they leverage WebGL because it's way more performant than using the CPU to do these calculations and rendering and whatnot. And really, A-Frame gives us a big advantage because we get to build 3D spaces with HTML markup. Now that we're using HTML markup to kind of build these worlds, we can also support DOM manipulation, which is super cool. A-Frame itself is a little bit more VR focused, but for our purposes, we are going to use it for an AR experience. Now, I want to show you guys kind of what the VR experience for A-Frame looks like. So take a look at this demo. I pulled this straight from the A-Frame website. You can see here if I refresh, you get some nice little animations. You can look around. You can move around as well with the arrow keys and whatnot, and you can also enter something called the headset mode. The headset mode gives you the full view, and if I did have a headset on right now, it would track my head movement up, down, forward, back, all that. So let's look at some of the A-Frame markup. If you're familiar with web development, you're probably going to be familiar with what's on the screen right now. We have our basic head where we have our A-Frame script included, and then we have our body, which includes our page. If you notice here, we have a scene which holds all our primitives or entities or whatever you want to call it. Our scene is going to be a container for everything that we do in 3D, and we can actually plug that into anywhere. So the nice thing about that is A-Frame is going to support any of your single page application frameworks like Angular, React, Vue.js, and it plays nicely with them, just because it is fully revolving around HTML entities and whatnot. Now, if we look inside our scene itself, I've highlighted a couple of these things. I've highlighted the A box, I've highlighted the A plane, and I've highlighted A sky as well. In A-Frame, these are called primitives, but we're going to call them entities for now to make it simple. A box is what you kind of guess it would be. It's a 3D box. A plane is what you'd also guess it would be. It would be a 2D plane that we can place in our world. And a sky is a little bit confusing, but it's really just a background. It's a background to kind of overlay the world that we are in. So primitives don't really do much on their own until you give them attributes. We're kind of familiar with HTML attributes, and A-Frame leverages this really well. You can see some of the basic attributes like position, which gives us an idea of where the element would be in three-dimensional space. Gives us the rotation, which again, very simple, the rotation in three-dimensional space. And I've put in color here just to give you an idea of what that would look like. You can see the color values accept a lot of the things that we're used to in CSS, like actually declaring the color itself, using a hex code, or using RGB codes as well. So I have a little JS Fiddle demo we can look at, and we can just try to play around a little bit. Alright, so let's move over. So this is the markup we had previously. You can see inside JS Fiddle this actually runs perfectly fine. I can refresh the page, nothing janky going on here. If I do move things around, you're going to see that reflected instantly. So let's say we move a box. Instead of being -1 for its x coordinate, we're going to make it 1. If we rerun, it's off to the right a little bit. If we, instead of having 0.5 for its y, we set it to 1.5, it goes up a little bit. Very simple. We can rotate things and whatever, but we'll play around a little bit more later on, and feel free to use this link to play around and see what you can come up with. Okay, so before we continue on, the next thing I want to talk to you guys about is ECS. ECS is a design pattern used for video game development, and A-Frame uses it as well. ECS stands for the Entity Component System design pattern. And really what it is, it leverages entities, components, and systems to build applications. Now, what exactly these are is we're going to get into right away, but keep in mind ECS frameworks and design patterns really allow you to reuse your components and reuse your logic as much as possible. That's really the main goal behind it. So the first part, entities, we've kind of went over this a little bit, but I'll highlight them again. So we have in our little markup here, we have a box, which is an entity. It's a thing in our world. It's a base object. It can have properties like we brought up, like position, rotation, color. Without really these attributes or components, entities don't really do much on their own. Think of entities as kind of like empty divs. If you don't give them any sort of classes or properties, they're not really going to do much. And in A-Frame, they don't like to use the word entity. They use the word primitive, but I think it makes sense to use entity for now. Okay, so the next part we're going to talk about is components. Components are the second part of ECS, and really they hold data for our entities. So we look at our A box here. It has a component for position, which gives it data for its position. It gives us a component for rotation, which gives us data for its rotation and whatnot. Now, components are meant to hold data, and they can add functionality, but really think of them as CSS classes, where we want to kind of style something or give some sort of specific functionality to something, or define the functionality of something, kind of. Components shouldn't really do too much logic for us here. They should really just hold data about how something should function. Okay, and the last part is really systems. Systems are a way to decouple component logic and data. Just like how before I was telling you about how components shouldn't really do any of the logical operations, systems are built to do that. Systems are the singular place where you want to have all your logic and whatnot written in. So systems would look at all the components on an entity and really figure out what to do with it. This is nice for us to kind of decouple these two so that we know one place to update all our logic, and we can just keep reusing whatever we want in inside our components and not worry about it. Okay, so here you can see I added a new script tag. This is for an A-Frame physics system, and really just by importing it I can use it. I use unpackage to kind of take a npm package and expose its distributables and whatnot, just to make this demo easier. I don't want to go into installing things and whatnot. We'll talk about unpackage a little bit more later, but let's look at the change to our body. We can see in our scene now we've added a system called physics, and this is directly something that's made available to us from this A-Frame physics system. And we've updated the position of the box. We've moved it up to 4 instead of I think 0.5 before. And we've added these two components as well. The box is a dynamic body, and the plane is now a static body. Let's take a look at that. Alright, so remember our previous demo here. Let's take a look at the new one. Okay, so very similar. Positions at 4. Let's start. Okay, look at that. So easily, we already have some physics in play. You can see it bouncing around. We can maybe change the angle of this plane. And look at that, it slides off, goes off into the abyss. Very easy to kind of understand what these systems do. Think about it with maybe, you know, a couple words we were able to create this kind of experience. Awesome. Okay, let's see if there's anything else I want to say about this. No, that's about it. So yeah, just to review, We use unpackage to display this, or add this to our page. We added the physics system to our scene. We updated the position of the A box, and we've added 2 more components called dynamic body for A box and static body for A plane to kind of achieve this. Now, really, this page is focusing more about ECS. We're talking about some of the pros and cons of ECS per se. Like I said before, really ECS focuses on building reusable components. Once you build a set of components in a system that governs what they do, your logic can be applied to any of your entities. So this is great. We really want to use this for the kind of applications we're going to be building, where we're going to have maybe a couple, think about it like a couple maybe units, and they're going to all want to do certain things, like they're going to want to walk or they're going to want to attack. And having components in place that just sets the data for them differently, it's a great way to go forward. Another nice thing about ECS is that we get to avoid some of the issues with inheritance chaining and whatnot. Once we have objects like, let's say an eagle, which is going to be of class maybe bird, and then vertebrate, and then animal, and then microorganism or something like that. And we want to talk about something like, we want to find out where the move function is implemented. Like, how does the eagle get from place to place? How far back in our inheritance chain do we really need to go before we find out where this move function is? Is it in the bird superclass? Is it the vertebrate superclass? Is it the animal? Or is it even all the way back at the microorganism bioclass? Okay, and so I guess those are some nice things about ECS, but now where are the negatives? Since most of us are web developers or could be web developers, we're probably used to hearing about MVC or MVVM, and learning about ECS is a little weird because all the parts are kind of separate, whereas MVC and MVVM are a little bit more integrated and closer coupled together. So it may be weird. You might not know where your controllers are. You might not know where to put logics in some places. And you might want to put logic directly in your components and whatnot. Also, another one of the, I guess, disadvantages would be how components are added to HTML entities. You might have noticed that in our previous example, we had a couple components per entity. It does get a little bit daunting when you want to add like 20 components to something. It does get a little bit over the top, and it does get a little annoying, and it does look a little ugly. But I think we can get past that with a little bit of practice. Okay, so A-Frame's ecosystem. You can see on the screen here right now that I have this nice little demo GIF of one of these packages available. This is something just like the physics system that I showed you guys before. It maps the center of a screen to something that displays the angle of whatever's at the center of the screen. Super cool, and you can get started with tools like this and whatever's out there just by simply looking up on NPM and looking up the A-Frame component. Or A-Frame has a specific registry themselves of packages they like to highlight. So if you want to check them out there, that'd be great. This is really a side effect of ECS. There's this massive ecosystem of component libraries and whatnot available to you because of how ECS is structured. And whenever someone builds a system or builds a component, they can share it with the whole world really easily. You don't really need to do too much work to kind of pull things out and use them and share them. Just a minor tip, I talked about unpackage a little bit earlier. Unpackage is a really nice way for you to kind of test these libraries before you even want to install them, so you can just directly import them into your page and kind of play around with them before you want to make them a local dependency. And yeah, so it kind of brings us to the question is, do we really need to use A-Frame? I've talked a little bit about 3JS, and there's some other alternatives out there. There's React 360, and I think a couple more will be popping up over the next couple of years as VR and AR kind of picks up steam. And yeah, the question is, do we really need A-Frame? Yes, I like A-Frame. It really simplifies 3JS. But not really. You can do everything you want using 3JS. You miss out on, the ECS framework that A-Frame uses. You miss out on manipulating objects using the DOM. You miss out on all the A-frame ecosystem libraries that are available to you, you miss out on device support, which is all the headsets, the controllers, and whatnot. And if you guys don't believe that A-frame makes things simpler, I want to show you guys kind of what a Three.js example would look like. Okay, so this is taken from the Three.js website. You can see here we have this lovely demo of a couple 3D shapes and whatnot, and they're drawn for us. Okay, great. So let's take a look at what this code base looks like. Okay, so I'm going to skip past a little bit of this stuff. It's just setting up HTML and whatnot, and we get to the meat of it. This is all the JavaScript stuff starting away, and we have a couple variables getting set that could seem a little daunting. None of them are defined yet, but if you look, we have a container, we have stats. Seems okay, nothing crazy. Then we have our camera, our scene, and our render. Starts to get a little bit more dicey, right? Let's move down into our initialization function. You can see we're doing some nice HTML stuff. We can ignore this stuff for now. And there we go. We start to see our Three.js stuff coming in. So, all right, we're creating a new scene. Sure, sounds fine. Then we're creating a background. So this is using a specific Three.js color. What is that? You have to instantiate a color? And have you guys seen a code like this before? Probably not as a web developer. After that, we're looking at instantiating camera. There's a perspective camera. There's some angles, aspect ratios, maximums, and mins. Do we really want to deal with that? Do we even want to deal with the type of camera that we need to select and kind of get that knowledge? Might not want to get that in depth. Next, we got to talk about lighting. What kind of lighting do we want? What color is the lighting? How much power the light has? Yeah, it gets a little bit daunting, especially once we get to like texture loaders and all that kind of stuff. And you know, just for that small little demo, to take a look at how much code we had to kind of push to kind of get that working. There's there's a lot to look at, and a lot of what A-frame abstracts away from us. But let's say you are one of those sticklers and you like to get really deep in there and you really do like to work at a lower level. I'd highly still recommend using A-frame just so you can abstract away the annoying parts, and A-frame still makes the Three.js API available to you. So if you did want to draw all your shapes in a custom way, feel free, nothing's stopping you. The Three.js library is available, but you can still use Three.js to create your scene while leveraging A-frame to do some of the more annoying stuff for you. Okay, so can we even use A-frame right now? A-frame is supported by all modern browsers. Now I say all with an asterisk because really it's all modern browsers that support the WebVR spec. Now if you go look up the WebVR spec, it doesn't really exist anymore. The Immersive Web recently pushed out this new spec called the WebXR spec that was released only a couple months ago from this recording. And really browsers haven't picked up on that just yet, but the WebVR spec was supported by all major browsers. And the Immersive Web team actually released something for mobile browser support as well. This is like a polyfill you can use, and there you go, you get support for mobile browsers as well. And the nice thing is that you get to use VR headsets as well. It's already built in. You don't need to really do much. You can map some controls to them, but you know, all the major brands are kind of supported. You got the Vive, the Oculus, the Googles, and then whatever. Yeah, I think I've touched up a little bit about the WebXR spec, and really what's next is the Immersive Web team is going to be releasing that, and they've already specified the spec, and really just comes down to the browsers implementing the WebXR spec a little bit more. XR really stands for extended reality, and it's just the mix between virtual reality and AR, and the next step. And what they're trying to add is some more like motion controls and things like that to the WebVR API kit. Okay, so that's about it for A-frame itself. We're going to start talking about some detection libraries. To build a proper AR app, you're going to need something to detect what's going on in your video feed. And once you can detect what's going on in your video feed, then you can start kind of mapping shapes to the page or whatever you need. You can do things where you're doing like a custom TensorFlow image detection model. These are pretty involved, and if you don't have a background in machine learning, they might be a little bit daunting to get started with. But there are more simple libraries, like just something that detects like a marker or something, and you can display off of that. Or we can talk about some of the ones that I've kind of ran into, and they're pretty useful. First one is WebGazer. WebGazer gives us a way to kind of interact with the screen using our eyes and our face and whatnot. It's an eye tracking library built by Brown University and the University of Auckland. It's passively calibrated based off user interactions with the browser. So as the user moves their cursor around, clicks on things, it starts to calibrate itself and kind of learn how you use your eyes and where you're looking based off of that. Obviously, you're going to need webcam access. It is, well enough, Java script or library, which is great. This is all going to be front-end client facing. There is no server-side processing involved, so it's self-contained. Okay, so let's move on to Jalees. So Jalees is an object detection library. It focuses on mainly facial detection, but it does have some support for detecting objects and other common items. You can see in the picture I have on the screen that they're using it for like this glass trying on application, which is super cool. I'd recommend trying it out. I think they showcase it on their website. And really what sets Jalees apart from some of the other detection libraries is that they built their own let's say neural net engine. So a lot of the detection libraries out there right now, they just use TensorFlow to kind of build their model, and then they run it with TensorFlow.js. Now that sounds great and all, but TensorFlow.js doesn't use WebGL as well as Jalees does. Jalees' engine is built to run neural nets on WebGL, so it seems to be way more performant. So this is really nice when we're talking about mobile GPUs and whatnot, whereas they're not going to have as much horsepower as standard desktop users. Now I think I'm going to add a little demo to this page. I wasn't able to get the demo running at the same time as this capture software, so you should probably see my my head with the cube mapped onto it, and you'll see it'll follow my head back and forth, left and right, and if I turn up and down and all that. And you can probably notice it's pretty snappy. So if I'm moving my head around quickly, it actually does a good job keeping up with me. Let's move on. So the next one we have is FaceAPI.js. This is an open sourced library. It runs on TensorFlow.js, so it is a little bit less performant, and it is focused mainly on facial recognition. Because it's fully open source and because the developers have been working with it for a while, it does allow you to kind of switch out the model. So that's a nice thing. So if you want to take on that challenge of building your own face detection model, feel free. You can plug it in with no problem. Now with FaceAPI.js, it does support some nice things where it does detect outlines on your face. You can know based off points where people are looking, the directions they're facing, what kind of emotions they're displaying. I think I'm going to show a little bit of a demo here where you're going to see me try out a couple other emotions. You're going to see me moving around. You're going to see kind of an FPS counter, and you're probably going to see it around the 10 to 20 range. My computer does have a dedicated graphics card. It is a mobile-ish graphics card. It is an RX 580, so it's pretty new. It does have quite a bit of dedicated memory. Most users won't even have this much power, so you need to consider kind of what you're going to be doing when you're building an AR application. Do you really need to run these massive neural nets to kind of do what you need to do? Other than that, I will also show you guys like the scene demo that we built, and really it's going to try to do the same thing. It's going to be moving around, rotation, up, down, all that kind of stuff, and you guys will see a lot of jittering. You guys will see a lot of I guess dropped frames and whatnot, and you'll kind of see the difference between Jaleesa's implementation and interface API.js. Other than that, that's it. Thanks everyone for coming to view this video. If you have any questions, feel free to reach out to me or Aquent DEV6. We'd love to help you along this journey, and thanks for your time. Bye-bye.